Hey fellow engineers, and welcome to 2021 Festive Tech Calendar. Hopefully you're well and enjoying great content here on the calendar. I know I am. My name is Timur, and I am an Azure Solutions Architect here in beautifully locked down New Zealand. Coming from many years of software development background, I help fellow engineers and businesses overcome technical challenges. In spare time, I love solving puzzles, enjoying fine wine. Even better, if I can do both at the same time. Big shout out to Gregor and Richard for hosting the event and being kind enough to let me join in the fun. Christmas has a very special place in my heart, and Festive Calendar is a wonderful occasion to share the love. Now, with pleasantries done and dusted, let us start. Zero to high functioning serverless hero. We'll start with a bit of a fairy tale. Once upon a time, a bright but naive software developer took on a new job right before Christmas. What can possibly go wrong if I'm going to work for a kindest of corporations, he thought. Christmas is the perfect time to start a new adventure with Santa's helpers. Can't wait to join their IT department, he thought. He was thrilled to be the first person to come into the office in the morning. He flicked the lights on, had a look around. The office was empty, with a lonely piece of paper sitting on one of the desks. The developer picked it up and read it. Today is your first day at Santa's Helpers IT department. We have an important event coming up and need you to quickly put together an API for our Road Warriors team to be able to use. Oh, and one more thing. All your teammates had quit last week, so you are authorized to use magic to get things done. Ho, 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 the management. Alright, things didn't go as expected, but hey, we still have 13 more days before the release. Can we do this? Yes, we can. There's still plenty of time to save Christmas. Right? Moving on to the task at hand, today we're going to be standing up a serverless Azure Functions API with some optional extras that may help us in the future. Let's dive in. First off, let's take a look at the API spec, which our previous teammates have conveniently left us. Apparently, Santa needs us to store a list for him. It appears to be a list of children who have been naughty and nice. Luckily, there's only one endpoint, and we only need to support fetching a list by city and adding new entries to the list. It seems there's no need to update the values, as Santa has already double-checked the object before sending it to us, so mistakes are effectively ruled out. With the task being crystal clear and only 14 days to go, let us not waste more time and keep going on. Alrighty, we'd fire up Visual Studio and Bootstrap an Azure Functions project. It'll also help us in the future if we had access to Swagger UI, so we'll pick that option from the start. Yeah, there's probably nothing else we need to change, so let's just keep creating the function. And while Visual Studio prepares things for us, I think it is a good time for us to enjoy one of the benefits Santa's Helpers offers, and that is unlimited access to mulled wine and eggnog. Grab a cup of hot tea, turn on your favorite Christmas carol, and check back in a couple of moments. Now, with hydration break successfully completed, it is time to quickly build up the Azure Functions project. It's got a few things going on, but since I wanted to talk about Christmas magic, I tried to quickly get through basic setup and focus on source code generators instead. For more details on getting started with Azure Functions, check out my blog or other resources online. Before we dive in, let's bring API spec back in front of us so we know what we're building. I'll try to nest them both on the screen. So we have two endpoints. Let's create one. We'll call it add child and just basic HTTP trigger and create another one. We'll call it, what do we call it? Let's call it get children. And again, just a basic HTTP trigger. We can probably remove this one. Alrighty. There's also one thing that we can potentially change pretty much right from the beginning, is that little /API endpoint that I'm personally not a fan of. So to do that, we'll have to modify host.json and add an extension here that defines our behavior. So by default, we would have had an API prefix in here, but the spec doesn't have it, and so we shouldn't either. Now, we've got function names, and in this case, I believe it should be, well, get children is probably okay, but we know that get children only supports a get, and the route for that is going to be child find by city. Let's also fix up this route. So it instead supports only post methods, and it only works with this route. Right. Since we are able to use OpenAPI extension in here, why don't we go ahead and define what our endpoints actually do? To do that, the easiest way is to start decorating our function with attributes. OpenAPI operation, and that, I believe, basically has an ID, so we can probably just call it run. And we also need to define what our inputs and outputs are going to be. So this is OpenAPI request body. For the type of request, we'll just go text JSON, and for the type, well, we actually don't have a type for now, but we'll have to create one. So why don't we call it child? While with em, OpenAPI response. And in here we want to say that we have created an object, HTTP status we also want to return text JSON, and the type is gonna be of the same entity, child. Well, apparently this is what we need to do. Now let us go ahead and create this class. I'll just create a folder for it. Let's call it models, and we will stick it into there. Let's have a quick look at what the object should be, and the spec says it should have ID, first name, last name, city, motto, whatever that may be, and whether the child has actually been naughty or not. Let me quickly copy and paste this value so we don't have to spend too much time on it. Exactly as we just said, and now we can use it. Nice. Let's also quickly bootstrap the getChildren function, and I'll just cheat and copy and paste the code from my notes. this is what it should be. Anything that we may be missing? No, not really. Nice. Yes, so at the moment, the functions don't really do much. We've just set up basic routes, we've set up types, and we've set up some OpenAPI definitions. Maybe why don't we still run it and just quickly see what it looks like? Oh, doesn't want to run because we have not imported a namespace. Sure, fine, nice. We won't bother calling the actual endpoints because we know they're not functional, but what we can do is we can have a look at the Swagger UI. This is our local functions definitions, and all we had to do is define a couple of attributes. As you can see, it is looking fairly similar to what we have got from our ex-teammates, which is nice. We didn't have to do much. Now, let's go ahead and maybe define some more stuff in the function to make it, well, functional. So instead of having all of this, right, we don't really need it. We'll just go ahead and return new object results, and we will go new list of child. It still is empty, and I could potentially just have gone ahead and done new child and create all the properties in here, but let us take it a step further. Since we will need more stuff in the future, why don't we just add dependency injection to this function? To do that, we will have to install a couple of things. OpenAPI extension. To do that, we'll just go ahead and right. What we can do is we can define a class. We can call it startup. And in that class, we will register our objects and our services, and this will come in handy later. But for now, let us just assume that we have a singleton child. We'll call it the child, and we will use that. For the runtime to pick up our startup, we will have to do this, which effectively marks our class as startup, and then we can just inherit it from, I believe, functions startup. I may have to implement it. This is where we can register services, and as I said, let us register one child. That will just work with for now. Builder services, add singleton, and we'll just call it new child. We can give him an ID. Namespaces. Name. We'll just call him Ivan. Last name Ivanov. And let's say our Ivan lives in Moscow, and he has not been naughty. Some people are nice, right? Good. The way we can inject the service into our functions is to first of all make them non-static and use a constructor. So we'll just go ahead and implement one. We just injected child. what we can do then is we can use it. Right. In here, we can literally just supply one. Adding it to here will probably make no sense because we want to add a child, not query for one. But I'll just remove all the code in here because it doesn't do anything anyway. Maybe we'll leave one, just so it still compiles. And yes, we actually happen to have a database that's already stood up for us. Why don't we install Entity Framework and use that to our advantage? So now the question is, why am I installing a very specific version? Well, you'll have to trust me, but this is the only way that I know of for the OpenAPI extension to actually work with Entity Framework Core. It may have changed since the last time I looked at it, but I don't want to risk it for the demo, so we'll have to roll with an old version. I just want to ensure that our packages are actually of the correct versions, and yes, they are. So with that out of the way, we don't really have to worry about it too much. Let us create a database context for our database. I'll just create a new folder in here. I'll call it infrastructure. And we'll create a class. We'll call it Sunday Helpers DB context. I will inherit it from DB context, of course. And what we will need to do, I'll just make it public, is do on configuring. This is where we will go and say option builder, use SQL. I will pull down a very secret environment variable that I have predefined, so I don't have to divulge my super secret password to my local SQL Server instance. Clean it up a little bit. Now, we also want to ensure that we define our table. And the table is called clients, which is a bit counterintuitive, but this is what it is. And it holds objects of our type. Now that we've defined our database context, let us go ahead and register it with our dependency injection. And the way we do it is we go back to the startup class and add it into here. We even have a helper method for that, which is fantastic. The way to inject it would be to go to our function and add a parameter to the constructor. Then I guess we want to be able to use it, so let's create a field. Returning hard-coded list is fun, but it's probably not what we wanted, so let us go ahead and go clients, where we'll need to import this. And since we have two parameters, city and whether a person has been naughty or not, let's just use that. So we have a city equals city. We'll define it in a second. And the way we extract parameters from query is very simple. We just use the object that's been passed on to us and get it from query. So that would be our city. And for the other one, since it is actually a Boolean value, we'll have to parse it. But that's about the only complication. Well, I think we've got something. Yes. There's no nice people in Providence, apparently. What about naughty people? Oh, yes, there's one. Okay, fantastic. So now we know that we can query the database and at least half of our API is done. Now, what about adding children? This is obviously not working, so we will have to add it. Let's go ahead and do that. With Entity Framework, it should be simple. First of all, let's inject our context into another function. We'll have to unstatic it first. Don't need that. And I'm happy with the field. The way we get values from body is a bit more involved. I will just cheat and copy it out. Basically, we get request.body, wrap it inside a stream reader, read it all the way to end, and then if we want to get it, we obviously need to go ahead and convert our request into an instance of a child type. We know that if we insert things, it probably makes sense that we don't really feed custom IDs, non-standard IDs to the database. So let's just ensure that if our ID is something that's not 0, we will throw an exception. The way we add it into the database is adding it to the collection and saving changes. This is all simple, and since we want to return a created at object, I believe we just need to change this to created at. Probably created at result is okay, isn't it? Maybe just created result. Yes, we will say what kind of path it was and we'll return our value. So with this, we should be able to go ahead and save data. Let's quickly give that a go. Now I'm fairly confident that we've got most of the plumbing out of the way, but it never hurts to double check. And yes, as you can see, the ID we get back is something that's definitely not what we sent. So my understanding is Entity Framework has assigned it back to an object, and this is what we get. Nice, fantastic. What else can we do to improve it? You probably have noticed in here that the way we do it is we have to pass an ID even though it's, well, not used. So we can potentially delete it and we can send another request, and yes, it'll work. But it actually is not the best practice, because we may accidentally expose internal data structures to the client and it creates more traffic. We also can leak something sensitive to the client. And on top of that, sending the same entity to the client couples it to our data model, which effectively limits us in the ways we can change it. The solution to this problem is usually introducing a new layer that is called Data Transfer Object, or DTO, and we can do it fairly quickly, right? So let's just quickly create a new model here, and we'll just call it child DTO, I guess. Well, actually no. Since our DTOs are specific to the API requests, we should have different DTOs for different actions. And in this case, it would mean we should have a DTO for create and DTO for update child. But since we know that Santa is confident in his ability to not mix up values in the objects, all we have to do is create. In this case, we'll just get away with using one. I'll call it create child DTO, and essentially all I will have to do in here is I will have to copy everything but the ID, because that's the only property in here that we don't want, right? This is what it should roughly look like. Nothing special. Now we just need to update our function to expect that particular value in the request. And we should also map it, because now in here we're getting a create child, but well, this is not a problem anymore, but we still need to add a child in here. So what I will do is I'll just go ahead and start with first name and kind of go like that all the way. And as you can see, it quickly gets boring and tedious. And the worst thing is, if something is to change, we will have to update everything. We will have to update mappings, we will have to update DTOs, and if we had a bit more complicated case, we will actually have to update more than one. So I consider us lucky having only one small DTO, but it does take a bit more than that. We've got everything here, and it should work exactly the same, but we should only have the fields that we actually care about sending, well, and receiving. Now we have only the fields we care about, and we have two model definitions in here. So this is what we send, and this is what we get back. I wouldn't even try to run it because we know it works. As I mentioned, it gets a bit tedious and boring to try and maintain these. I wonder if we can apply some Christmas magic to this particular part and make it work automatically. And yes, apparently there is at least one way to do it. It is called source code generators. What we effectively need to do here is we need to create a library that is targeting .NET Standard. I'll just call it class library. Generator. It has to be .NET Standard 2.0. I believe that's the only limitation to this particular method. We've got our library and we need to install some NuGet packages. A couple we need to install is code analysis C#. I'll just quickly add it. And another one is analyzers. So I'll just quickly pop that in as well. This is all nice, but it's not doing anything. For it to actually work, we need to reference back to it from our main project. And the way we do it, we'll have to go ahead and edit the project file and add a new item group somewhere at the bottom of it, like so. And it already happens to point to our project. The main point here is it has to be of output item type analyzer, and I believe it can either reference an output assembly or not. Since the tooling is a bit new and has not yet been polished, after you've done this, you usually have to reopen Visual Studio. But let us first create our first generator, and then we will reopen it and test it out. To actually create one, we need a class. I'll call it, I don't know, DTO generator, for example. It has to be decorated with a very creatively named attribute. And it has to implement a source generator interface. It runs in two phases. The first one is when it initializes, and the second one is where the actual generation takes place. Initialize is effectively an opportunity for us to see what kind of syntax constructions we need to inspect, and this is where we will emit our source code, and that'll get to the compilation. For the very simplistic case, we will not initialize anything at all, and we will just return a hard-coded DTO from what we've already got, right? So the way to do it would probably be to go text and all we have to do in here is basically just add whatever we had in our DTO definition. So instead of having it in here, I effectively go ahead and move it all to the generator. If we have a look into our function, surely it is broken. but that is where this will come in handy. Now, we have just created a bunch of text, but what we need to do now is we need to return it back to the compiler. And the way to do it is to add it onto the context. So we go ahead and say context add source. I believe we need a hint to it, so we'll call it create child DTO, and we'll create a source text from our string builder. If we just build it now, it should at least build with no issues, and yes it is. We'll rebuild everything. But as I said, for us to pick it up, we will have to reopen Visual Studio. This is the only annoying bit that you have to do, but you only have to do it once you have created your generator. Now to reopen it. And now we've got this new dependency in here called analyzers. It has a generator inside of it, and inside that generator we've actually got a create child DTO, which has basically been automatically injected here for us. Let's have a look at it. Oh, look at that. Isn't that our code? But as you can see, the file is auto-generated, so cannot be edited. Thing is, we don't really want to. What happens now is this type is linked to our generated source, and we can even navigate through if we wanted to. But fact being is, it just works, right? Christmas magic. Obviously, it's not very useful if we don't do much, so we will have to start adding some logic. What I usually tend to do, there's heaps of ways to do it, but I really like having custom attributes that I will mark my entities saying, hey, I would like a DTO for that. Let's try and use that approach. For that, I'll just create a custom attribute in here. I'll start by decorating the class. I'll just call it generate DTO. Yeah, that's a good name. And we will have to create a class. That's the class. It doesn't need to have anything at all. It just needs to exist. And we are done here. Now on to the generator itself. As I mentioned, initialize is a place for us to hook into the pipeline and inspect classes or other syntax elements that are being worked on now. So this is where we would want to inspect every single class definition, because this is what we decorate, and see if the class has an attribute with a given name. The way to do it is to register a so-called syntax receiver. So let's just add it in here as context. Register for syntax notifications. And I believe it accepts a function, a lambda, where we would just go ahead and say new model definition receiver, something like that. Now we obviously need to create the class. And in the end, we'll have to implement onVisit syntax node. So this is the most important part of this, right? All we have to do here is we have to verify that the syntax node we're currently looking at is a class declaration. See if it has any attributes on it, and if these attributes have a specific name. I wouldn't bore you by typing this whole thing again. I'll just copy and paste. We just need to fix things up. Once we have determined that the class needs to be processed, we'll just add it to a dictionary, and that's probably the easiest way to do, so that then we can extract it later on and work on it. Let's just initialize it from somewhere. A constructor is good enough, right? Right. That part is done. We don't have to come back here anymore. We'll just have to replace contents of this method with a bit more logic. We need to extract syntax receiver from context. So let's do that. We don't need it. So that would be context, syntax, receiver. We know that it has a property that we should loop through to actually find out what classes we need to process. So it should be something like that. And for each class, we basically want to loop through all the properties and copy them out to our new class. But before we do that, there's one thing that always catches me up by surprise. Every single time, it is namespaces. Obviously, we can just hard code some namespaces, but what if our DTOs, our entities are a bit more involved and they actually have non-standard references? So the way I tend to do that, I just copy all the namespace declarations from the class that I can find, from this particular unit I can find, and I just add them onto the new file. So let's do just that. Again, I wouldn't really bore you by typing it out, but it basically is just copying namespace declarations and combining them into one list that later on we write out into our new string builder. So this is the beginning of our new source code file. And once we're done running through all of these, we will have a list of usings. After we've done that, we just need to start writing out a normal namespace, our own namespace. One way we could do it is, let's just go ahead and add line, append line. So we go ahead and start going off with namespace. Let's use the same namespace that our model is in. That way it'll be easier for us to find it in the code. So I'm all in for that. I believe that is called class to process. And we want a parent of that as namespace. And obviously the opening squiggly bracket. Now that we have our namespace, and I probably should bring back the code that we just deleted. Let me quickly paste that in. So the thing we're generating is looking something like so. Right. And it goes namespace, then class declaration, all the properties. So there's two parts to this exercise. We need to define properties. And then again, some people might get mad at me for sticking methods into DTO objects. I kind of think we can get away with that because first of all, it is a very simple DTO. The code is generated and that hopefully illustrates the purpose. You can generate it in different class. It's just easier to see on the same screen. We will define our class in here, which is basically create our old class name and DTO suffix. So if we have a child, that'll be create child DTO. And then we'll have to loop over all the properties. And again, this is a bit involved. I could have typed it out, but this is what it should be. You basically find all the property declarations on the class that are public, and then we just loop over it. We'll call it P. And in here, we want to not include an ID. And again, there's heaps of ways to do it. There's a million ways to do it. I'll just resort to the most simple and the worst one of them to illustrate the purpose, right? We'll just exclude it by name. Yeah, I think we need to make sure that we set the type correctly. But yes, in fact, there is a property declaration syntax. Every other property should get written out to the text, to the class body. But since in here we have these two distinct parts, why don't we create two other string builders and kind of populate them as we go and merge them later on? It just makes it for a bit cleaner experience, I suppose. So the first one we'll call is property declarations. That's going to be a new string builder, yes. And the second one is the method where we map entities back to our map the DTO back to our entity. So that'll be entity mapping, and it's again just a new string builder, nothing fancy. It's just with this one we kind of know that we want this method header, so I'll start typing it out right in here. I'll just go public. We will need to return the type, and we will need to go to entity, and there will be nothing in here. Something like that. The type is effectively a class name identifier, right? So all we have to do is just put it out in here. There may be other use cases. This seems to work for me fine, so I'll just stick to it. Another thing is we'll just have to go ahead and populate them. So it should be as easy as property declarations append line, and in here we add a new public something to do with the property type, so it should be property type. Then we have a name, and we just copy it out, but obviously it can be anything you want, and a bunch of getters and setters, so it'll be get set. That's it. For the mapping part, since we kind of wanted to have this, so it should look like this, right? This that we've already defined, so it's going to be to entity that. Then we are going to return a new child object, and I believe we should do it before we start looping. So it'll be entity mapping append line. We just go and add this return new type, and we basically just reuse the same type from here, something like that. And then we just go ahead and initialize all the properties, so it becomes an easy exercise of us adding the identifier for the property kind of equals to the same identifier, because, well, they are identical. And if you can see, there's commas in here, but the last one is missing, right? Because we need to stop somewhere. There's heaps of ways to do it, but the one I think is the easiest is going to be a flag. So if we ever reach this place in the code, we'll just say needs trimming true, and we'll define it like so. And now if it does indeed need trimming, we'll go ahead and cut last 3 characters out of our entity mapping. So that is in fact as easy as just setting length. So that'll be length minus 3, and 3 is because we have /r /n, and then we have comma /r and /n, because this is what append line is doing. Then again, someone might notice that different environments have different endline designations, and that is correct, which means you might get caught out by this. So before you do that, make sure that you either cater for your environments or find a better way. I'll just put a note here to do beware crlf in Unix, something like that. After we've done generating our entity mappings, we need to ensure that we do the closing bits, and as you can see, one has a semicolon, another one doesn't. So maybe we just kind of go like so, Or if we don't care about indentations in new lines, we can probably just do that. That'll be easier. Combining the parts together, we have separate parts. All we have to do now is we have to add the property declarations, and we go entity mapping, something like that. That should do it. But then again, we've just gotten up to this place, right? So we have this, we have just generated this function code, and we have two more closing brackets. If we forget them, it will be painful. So let's not. I'm just closing them off in here. So this one is closing a class, and this one is closing a namespace definition. We have done this for every single class, which means we have to add every single class to our compilation. We have a parameter, so instead of just passing a hard-coded name in here, we probably should do this class to process identifier, because that's what describes our DTO best. And that should really be it. Again, I believe if I change the generator, I will have to restart Visual Studio. I'm really hoping that this behavior is changed in VS 2022 when it gets released, which I think is a few hours from the time of recording. But in the meantime, I will have to reopen Visual Studio and see you in a few seconds. We are back. Let's just rebuild the whole thing to be sure and inspect our generated code. Looks okay, just something is missing. I wonder why. Clearly we have not gone through our property mapping. So let's try to figure out why. Oh, I think I know why. That's because we haven't decorated our class for some reason. So it's generate DTO. I am very much surprised why, but now even if it builds, we still won't be able to see it unless we reopen the Visual Studio, but it looks like it's not building. So let us figure out why. Create. Oh, that is not the right place, and maybe this is why it's failing. So this is our generate DTO. Oh, actually you can see it does change when we update. Oh, this is so much better. This is so much better. Is it actually correct? It looks like it is. So maybe let's try and run it and see what happens. So we have an add child in here, and it accepts a DTO, which is now an automatically generated file. So technically all we have to do is to run it and play with it. Let's have a look at Swagger. And yes, in fact, it is all in here, and sure enough, we can just use it. It probably is not fun if we don't change this at least a little bit, so maybe let's add more stuff and just keep rebuilding. So we'll just add another string, we maybe add another, I don't know, date time. We'll just call it created add, something like that, right? This is where it might get interesting because we are importing a namespace. So let's see. We didn't update anything else. We didn't update the code generator. We just updated the entity. And this is the beauty of it. We don't have to touch it once we set it up. Now it's running. Let's refresh and see what happens to our DTOs. Oh no, they all are in here. We could probably add even more attributes to maybe drive the way it works. So one potential enhancement I see going on from here is we would say DTO generator, something like update, create, and maybe we can also supply a type. For example, we don't want it to be int, we actually want it to be, I don't know, long. Something like that could have also been possible. I'm pretty sure that you can come up with better ways to handle the generation process, but as long as it's all in here, it basically lets you easily handle every single model change that you get and still be able to maintain only one copy of this class. I think we are in a good place. We've just built an API. We've successfully decoupled entity and data transfer objects. We were able to modify it as we saw appropriate, and it all took us only, what, an hour? So we still have more time, which is fantastic. I think the Christmas is saved and Santa will be happy with our API. With that, let's go back to the slides. Alrighty, that's all I had for today. If you enjoyed the content, please consider following me on social media for updates on my future shenanigans. That would indicate that I'm on the right track, and it would boost my motivation to keep going. Once again, thank you for watching and enjoy your holiday season.